Alright, welcome back. This is Fluid Mechanics homework number 3, part C. The problem statement is asking a pipe of length L and diameter D has fluid of viscosity mu and density rho flowing through at an average velocity v arising from a pressure drop of delta P. Write the dimensional matrix for this problem and explain how solving for the null space of this matrix yields dimensionless groups that describe this natural phenomena independent of the choice of units for mass, length, and time. Show how the Reynolds number arises from this analysis. So, in any scientific field, to describe a natural phenomena, you need a expression that is unitless. And the Reynolds number is one of these. So, equal to rho vd over mu, where rho is our density, v is average velocity, d is the diameter, and mu is our viscosity. So what are the units of these? We have kilogram per meter cubed, meters per second, then meter, over Pascal second. And we know that Pascal second can turn into meter second. And when calculating this, we know this is equal to 1, making this a unitless group. So, back to the problem. We have a pipe of length L and diameter D has fluid of viscosity mu and density rho flowing through at an average velocity v and a pressure drop of delta P. So let's set up our matrix. We're going to have our units on the side. So we have kilograms, meters, and seconds. And we're going to list our variables on the top of our matrix. So we have our pressure drop, our length, our diameter, our viscosity, our density, and our average velocity. And the way we're going to fill this out is based on the units of each of these. So our units of our kilogram per meter second squared. Length is meters. Sorry, this is supposed to be diameter. This is meter. Viscosity, kilogram meter second. Density is kilogram per meter cubed, and our velocity is meters per second. So now let's fill this in. So we have 1 kilogram in the numerator to the first power, -1, -2, 0, 1, 0, 0, 1, 0, 1, -1, -1, 1, -3, 0, and 0, 1, -1. So this is our matrix that we're going to be using, that we're going to solve for the null space of this matrix to yield dimensionless groups to try and solve for our Reynolds number. So let's put this into a matrix. We have 1, -1, -2, 0, 1, 0, 0, 1, 0, 1, -1, -1, 1, -3, 0, 0, 1, -1. And this matrix is multiplied by a certain other matrix of, of 6 x's, which will yield the null space of 0, 0, 0. So our goal is to solve for these x's and the different answers that these x's could be. So our first step, we need to get this matrix into reduced echelon form. So let's start by row reducing. So we get 1, 0, 0, 0. Oh, this looks like sixes. 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, -2, 0, 1, -1. And so we have our pressure, length, v, our average velocity, viscosity, rho, and our d. So we get 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, negative 2, 0, 1, 0. And finally we get 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, negative 1, 1, 0, 0, 1, 0. So now we can begin solving for our combinations of x that yield a unitless dimension. So we're going to call each of our solutions a pi. So we have pi 1, and we're going to have our 6x's here. So our pi 1 is going to be equal to, in order to, so remember these x's are multiplied by our matrix in reduced echelon form to yield our null space, which will be a unitless dimension. So our first set of x's, negative 1, negative 1, 1, 1, 0, 0, and we can remember that these are equal to our variables. So in other words, v mu over pl. So that's our pi number 1. And let's see, pi 2 is going to be equal to, let's write out all these x's again. And remember, this is a unitless. Zero, 2, 0, 1, 0, which rho v squared over L, which is also unitless. So this is our pi 2. And of course our pi 3. Zero, negative 1, 0, 0, 0, 1. So this is equal to d over L, which once again is unitless. Now, how do these solutions relate to our Reynolds number? So, if we take our pi 1 and divide it by our pi 2 and multiply this by our pi 3, we get, let's see, so v mu over pl over rho v squared over L multiplied by d over L. We end up getting rho vd over mu, which, as we can remember, is equal to the Reynolds number and is unitless, which shows a relationship to a phenomena in nature due to its unitless nature. And that is the dimensional matrix of this problem, solving for the null space of the matrix, yielding the 3 dimensionless groups as we talked about, and showing how the Reynolds number arises from that analysis.